Assalamualaikum, hi guys. We are going to learn about the second type of reaction that haloalkane can do. Apart from nucleophilic substitution, haloalkane also can do elimination. So for elimination, we have one reaction that you have to know. That reaction is dehydrohalogenation of haloalkane, or you also learn about this in reactions of alkenes, where you want to prepare the alkenes, you have to do the dehydrohalogenation of alkyl halide. We are talking about the same thing as haloalkane. So the reagents that you have to use is either potassium hydroxide or sodium hydroxide, and the condition is alcohol under reflux. So when this reaction happen, your halogen atom can be removed from one carbon of haloalkane and another one is hydrogen atom. So you are going to use hydrogen and halogen atom, but they must be adjacent to one another. And after you remove them, you will form double bond between the carbons adjacent to one another. So let's try two examples here. I have example 13A and B. So when you have this structure of haloalkane, it's more easier for you to give the number for your carbon atom. So let's say I give this one as carbon 1, carbon 2. So we are going to take out the halogen atom Br from carbon 1. So you must take hydrogen atom from another carbon beside it or adjacent to it. So we only got carbon 2. Carbon 2, you got three choices here. Pick any whichever you want. So I pick this hydrogen. Automatically, there will be double bond between these two carbon. So you will form alkene with double bond between carbon 1 and 2. And then you also got the side product, which is HBr. And then next one, we have in cyclic form. If you realize that this halogen is located at this carbon, so let's say I give this one as first carbon, and then after that I want to give this one as second, third, fourth and fifth. If you take a look here, the carbon adjacent to the first carbon is carbon 2 and carbon 5. However, you got one more, which is this methyl group. So you got three choices, but you want to take out the hydrogen. So let's say hydrogen from carbon 2. We have 2 here, but I just choose 1. Same goes for hydrogen at carbon number 5. We have 2 here, but I just use 1. So if you take a look here, the class of hydrogen at carbon 2 and carbon 5 is the same, which is secondary hydrogen. So if you take whichever side you want, it will form the same product. But if you take this hydrogen from this methyl, this hydrogen that attached to this carbon is primary hydrogen. So we got different class of hydrogen. So kita ada dua pilihan sekarang, sama ada awak ambil hydrogen daripada methyl group here ataupun salah satu daripada carbon nombor 2 ataupun carbon nombor 5. Both are the same. So kita akan ada dua pilihan products. So I'm going to draw when you take out from carbon number 2. So hydrogen from here, kita akan get rid with halogen here. This one and this one. Awak akan dapat double bond between carbon number 1 and 2. And then the next one, kalau saya ada another one product, which is saya take hydrogen from this methyl group, I've got the double bond between this methyl carbon and carbon 1. And then don't forget to get the side product, which is HCl. So either these two, you are going to determine which one is the major product by using Sayzeff's rule. So this one will be the major product and this one will be the minor product. So that is how elimination reactions happen for haloalkane. So I hope you can understand a bit about this reaction and try to do a lot of tutorial to practice your understanding. That's it from me. I will see you in the next video. Bye!